Okay, so welcome back to our discussion on assignment problem. In this video, we discuss a second example, which is a balanced assignment problem that is about maximizing profit. So let's read. A retailer has leased a new space in a shopping mall and wants to place 4 sections in 4 locations so as to maximize total profit. The table gives the daily profits in thousands of dollars when the sections are assigned to various locations. Find the assignment that maximizes total profits. So here is the table. For our 4 sections, we label them A, B, and C, A, B, C, D. And for our locations, we label them W, X, Y, and Z. The numbers here represent the profit when a certain section is assigned to a certain location. The numbers here are in thousands of dollars. Now, since the problem is maximized rather than to minimize, we will have an additional step. Let's call this additional step by step 0.5. Now, for this step 0.5, what we do is we get the largest number in the table and then change all the entries by performing largest number minus the number in that cell. So to do this, in our opportunity cost table, notice that the largest number in this table is 28. So what we will do next is to change all the entries by performing largest number minus the number in that cell. So in this case, we change the opportunity cost table by performing 28 minus the number in that cell. If you do that to each and every cell in the opportunity cost table, we will get this updated opportunity cost table. So this 8 is from 28 minus 20. 12 is from 28 minus 16. 6 is from 28 minus 22, and so on and so forth. Now, what is the meaning or the essence of step 0.5? By step 0.5, the maximization problem transforms into a minimization problem. And because this is now a minimization problem, we can go back to using the Hungarian method again. So if we perform step 0.5, our maximization problem becomes a minimization problem. So in this case, we can use the Hungarian method again. Let's recall the Hungarian method. For step 1a, we will get the smallest number in each row and subtract it from every number in that row. So in our opportunity cost table, the first row has smallest value of 6. The second row has smallest value of 0. The third row has smallest value of 1. And then the fourth row has smallest value of 4. So here are the smallest values. For the first row, we will subtract everything by 6. Second row, subtract everything by 0. Third row, subtract everything by 1. And then fourth row, subtract everything by 4. If you do this, you will get this updated opportunity cost table. So this is for step 1a. For step 1b, we will get the smallest number in each column and subtract it from every number in that column. In our updated opportunity cost table, the smallest number in the first row is 0. The smallest number in the second row is 0. Third row, you have 0. And then fourth row, we have 1. Now what we will do next is we will subtract the smallest number from every number in that column. So for the first column, we will subtract everything by 0. Second column, subtract everything by 0. Third, subtract everything by 0. And then fourth, subtract everything by 1. If you do that, you will end up with this updated opportunity cost table. So that's it for step 1B. For the next step, we do the optimality test. So recall that for the optimality test, we will draw the least number of horizontal and vertical lines needed to cover all the zeros. In our updated opportunity cost table, we see that we have these zeros on our opportunity cost table. Now let's draw the minimum number of horizontal and vertical lines needed to cover all the zeros. If you do that, you'll have 1, 2, 3, and then 4. Okay? Notice that the lines are not necessarily like this, but we will have the same number of lines needed to cover all the zeros. Now, once you have drawn the least number of horizontal and vertical lines necessary to cover the zeros, we check the number of lines. If the number of lines needed to cover the zeros is equal to the number of sections or the number of locations, then optimal assignment can be done. In this case, we proceed to step 3. Otherwise, optimal assignment cannot be achieved yet. If the number of lines is less than the number of sections or the number of locations, we have to proceed to step 2.5. In our example, we have 4 lines needed to cover the zeros, which is equal to the number of sections and the number of locations. In this example, we should proceed to step 3 right away. For step 3, we look for a row or column with exactly 1 0. Corresponding to this 0, we will assign the section to that specific location. Once a section is assigned to a specific location, we eliminate that row and column corresponding to that assignment. The reason for this is because that section is already assigned a specific location, and that location can no longer be assigned to other sections. We repeat this process until each section is assigned a location. Finally, we refer to the original table to compute the total profit. So in this updated opportunity cost table, notice that in the first row, there is exactly 1 0 right here. So that means section A will be assigned to location Y. Okay, next, notice that in the second row, there is exactly 1 0 right here. So in this case, we will assign section B to location X. Next, notice that in the last row, there is exactly 1 0 right here. So in this case, we will assign section D to location W. And then finally, we will have section C assigned to location Z. So we have assigned each section to specific locations, and this is the summary. Now, we have to refer to the original table to compute the total profit. The original table is this one. So section A is assigned to location Y, so that's 22,000. Location B is assigned to location X, So that's 28,000. Section C is assigned to location Z, that's 26,000. And then section D is assigned to location W, which is 24,000. So we see that the total profit is 100,000. Now, this is the assignment that provides the maximum profit. In this case, all other assignment will give a possibly lower possibly lower profit. So this ends the discussion on example 2.